Hello, this is Mr. Rasmussen with Algebra 2 and Lesson 113, and this is about logarithms and anti-logarithms. Now, that's something probably new to you. However, it's going to look a little different, but we do have a foundation to work on because a logarithm is really the same as an exponent, just with a certain distinction about it. That being said, I really direct you toward reading through this lesson line by line, word by word, because it explains it pretty well as far as what these two are and how they work. I will also seek to take the time here and give my explanation to teach on how to solve these problems. First of all, let's review some basic mathematical functions with exponents. If we have x to the 7th times x to the 2nd, right? Functionally, we would add those. That'd be x to the 9th, correct? So functionally, when we multiply exponents, we add them. If we have division of exponents, right? That's the same thing as subtracting them, right? So this one here would be x to the 5th, right? Division is the same thing as subtracting exponents. Then if we have exponents of exponents, if we have x to the 7th squared, that's the same thing as x to the 7th times x to the 7th. It's the same thing as multiplying those out. That one's equal to x to the 14th. Okay, so when we deal with logarithms, a logarithm really is the same thing. It's an exponent. And so when we deal with that, these same three mathematical rules apply. That being said, let's jump into defining some things here as far as what logarithms are. If we take 10 squared, right, that's equal to 100. The 100 part is our anti-logarithm. Okay, so our anti-logarithm is equal to just this number here, okay? And our anti-logarithm is equal to our exponent which is the logarithm, okay? And then it has the 10 is going to be considered our base, okay? So the 10 in this case would be our base. The 2 is going to be our logarithm. It's our exponent. And the 100 is our anti-logarithm. So we got to kind of learn that to be able to keep some things straight as far as using these new terms to say what we're directing it toward. So in this case here, if we were to ask for the log 10. Now in this case, all of our bases, it's always, you can use different numbers as your base, but in this case, when log is by itself, it's understood that it's to the base of a 10, and that's the only one we're going to use in this lesson besides the natural logarithm, which we'll look at in a moment. So if we do the log 10 of 100, okay, so if we do log 10 or log 100 next to each other, okay, or log 100, that's asking us to find the exponent. So asking us to find the exponent part here. So to do that, we actually have a log button on our calculator here. So if I hit the log button and then I put in my anti-log of 100 and hit equal, we can see that the answer is 2. And so what that is saying that my logarithm is 2 for my base or anti-logarithm of 100. Let's say we're going to go the opposite direction. Let's say that we're going to say the logarithm, let's say the logarithm is equal to 2, and then they're asking us to find the log of x. There we go. I think that's how we would put it. The log of x, so x right here is our anti-logarithm spot, is equal to 2. It's telling us, I'm pretty sure, that it's given us the exponent. It's given us the 10 to the 2 is equal to what? Okay, and to do that here, basically, we hit shift and hit log again. You can see that's the power of 10 button, and then we put it in there. We put 2 in the exponent spot, we hit equal, and we can see we get back to our anti-logarithm. So really our first question is that when we're trying to solve these, they're asking us, are we trying to find the logarithm, which is the exponent, or are we trying to find the anti-logarithm, which is the number that doesn't have an exponent? Okay, the other way to look at this is something called a natural logarithm. Okay, and so the natural logarithm, I spelled it wrong, natural logarithm, the natural logarithm is written as an E, or it's also a IN. So when we see the IN, okay, is synonymous with log. Okay, the log is the base of 10. In this case, if we see IN, it's natural logarithm. The base is E, which is actually a value. Just like pi is equal to 3.14, well, E has an actual value, and we see that in example 1 that will put that out there. Okay, so that one is just a little different in the sense that we have the IN button here, and so if we wanted to find out, let's say for example, they have 105 in the book there. If we were to find if they put a number 1 here because it stands for natural logarithm to the 1 power, just straight up. And if we were trying to find the natural logarithm of our number 105, our 105 is going to be our anti-logarithm, okay? Then that is going to be equal. How would we find that? Well, we push the IN button, we put in our number 105, we hit enter, and then you can see there that is 4.65. And so how we write that out? Well, it would be written out as E, okay, to the exponent 4.65 is equal to our 105. Okay. Okay, let's get into some of our example problems here. And I'm going to go to a new page so that we can see the calculator as well. All right, so example number 1 says use your calculator to get a value for E. So E to the power of 1 is equal to E. Basically what we're going to do here, right, we're going to use our natural logarithm button. And we're going to do that to, back up here. Hold on. We're going to do the shift, and we're going to do the E and do it to the power of 1. So shift and then natural logarithm. If we hit enter, there we go. So E is equal to 2.71828, and it keeps going there. Just like pi has a number 3.14, the natural logarithm is this number here, 2.72 if we round it to the 100th place there. Okay, example number 2 has us use we have 3 numbers here. All right, we have 3 numbers there, and then it instructs us to use the logarithm base 10 to change these numbers to basically to solve this and put it into one number there. You would get the same answer if you just multiply them out and then divide them in correct fashion, but they're using this as an exercise to go through and show you the logarithms. Okay, so this one here, if we were to write it as 10 to an exponent, basically we would hit log button and then 47832 equals, and that gives us our 4.68. This one here, hit our log button, 59463 equals. We get that one to an exponent of 4.77. And the bottom here, our log button, 0.000817 equals, and we get 10 to the negative 3.0, round that one to 9. Then we can see this one's in the denominator, so we can switch it to the numerator by flipping the sign. So the same thing there. And if we remember, go back to our rules there. If we multiply exponents functionally, we add them. So basically, we're adding these three numbers together. All right, and that gives us 10 to the 12.54 as an exponent, and then we want to find out what the anti-logarithm of that is, and that'll be our answer. So when we do that, we do shift log, which gives me the 10 to the power of, and we put in my 12.54 and hit equals, and then we get 3.4. We rounded to 7 times 10 to the 12th as our answer there. Okay, so we see in this one here, we took these numbers and we used the logarithm to change them into that format there, to then basically multiply the exponents to then change it back into the anti-logarithm or answer. All right, in example 3, we do the same thing, we just do it with the natural logarithm. So if I leave my calculator on here, we're going to take that same number, we're going to hit the IN for natural logarithm, put in my 47832 equals. So what that's telling me is e to the exponent of 10.7, and we'll round that to an 8. And then my next one here, natural logarithm, 59463, e to the 10.99. And then underneath here, change that one, we have 0.000817 equals, that's e to the negative 7. Looks like 11. Okay, then once again, if I take that on my denominator, the sign flips and I have 7.11. If I add those, or if I multiply them functionally, I'm adding them. So basically, I got 10.78 plus 10.99 plus 7.11 equals, and I have my e to the power of 28.88, and so that is my natural logarithm there, and I want to change that back to my anti-logarithm, my normal number. So I'm going to use shift IN, see the e there, and I put 28.88 in there, hit equals, and I get my answer of 3.49 times 10 to the 12th. And you can see it's a little different there with the number, but very, very close. So two ways to do that in addition to just simply multiplying and dividing the numbers out. Okay, let's look at example 4. In example 4, it says if negative 0.0325 is equal to log of e y, then find y. Okay, so my first question here is what are they asking me to find? This one here, the log of e, the log of y, natural log of y is this. So this is actually my exponent. Okay, so they're asking me to find. They're asking me to find the anti-logarithm. So if I were to set this up, I've got e of negative 0.0325 is equal to what? They've given me the natural logarithm. They're asking me to find the anti-logarithm. So to do that, I'm going to hit Shift and my natural logarithm button there, put in my 0.0325, hit enter, and I get a different answer, my mistake, it's a negative. I paused there. I've got it in a positive. Let's try that again. Natural, shift in, negative, pretty important there, 0.0325 equals, there we go. All right, and then my number, my anti-logarithm, my number is 9.968 as an answer. All right, so for that one, they asked us to find the anti-logarithm. All right, let's look at example 5. In example 5 here, it says if y is equal to 4302, find a log of y and then b natural logarithm of y. Okay, so in this one here, they're telling me that they're giving me the anti-logarithm. What am I trying to find? I'm trying to find the logarithm. Okay, so in this first one here, I'm going to hit log. I'm going to put in my number of 4302, hit enter, and so my answer for that one there is equal to 3.63. Great. This one here, once again, they're giving me my anti-logarithm. They're trying me to find the e, the natural logarithm. So I'm going to hit my natural logarithm button there, and then I'm going to multiply that by 4302 equals, and I get my answer of 8.367 if we round it that far. Let's round it to the, put a 7 here, round it to the 10th place. Okay, what is that actually meaning? Well, this one here is 10 to the power of 3.63 is equal to my 4,302. What that one means. This one, my e to the 8.37 is equal to my 4,302. Okay, and remember the e is the same thing as that first number. There's my e value. So like if I were to take, if I were to take my e, my 2.7 times 8, this to the power of 8, right? Not times 8, but to the power of 8.37. That's that would give me back to my anti-logarithm number there. Okay, the trickiest part of this is figuring out what you're trying to solve for. So let's work through the practice problems here, and let's put this up here. Remember, I've got my base, and I've got my exponent, and then I've got my anti-logarithm. All right. So practice A gives us x is equal to 1n 0.0052. So my first question here for this, so go ahead and work through these yourself. My first question, and then check your answers. My first question here is, what are they asking for? Am I trying to find the natural logarithm, or am I trying to find the anti-logarithm, the number that we start with? Well, in this particular case, they are telling us, they're telling us that that x, we're trying to find x, this times, notice if we do this times our anti-log, let me try that there. Yes, they're telling us that this, okay, our natural logarithm times our anti-logarithm, this is our number we're starting with, is giving me my exponent. They're trying to find this. So basically what it's set up here is 0.0052 is equal to my e, and they're asking me what the exponent is. So to do that, I'm going to hit my natural logarithm button there. I'm going to put in 0.0052, hit equal, and you can see my answer there is -5.2, and we'll round it to a 6. Okay, so this one here where it's written next to it, this says this, my natural logarithm times my e times my starting number, my anti-logarithm, gives me what the exponent is. Okay, let's look at B here. B says e of x is equal to 51.4, which is to find x. So this one's set up, it looks a little different, but it's really set up the same way. We're trying to find the exponent. This is equal to e. What is that exponent? So once again, the e means I'm using the natural logarithm. So I'm going to hit that button there. I'm going to put in my 51.4, hit enter, and I get 3.94 as an answer, as my exponent. Okay, so that one there, they're giving us the anti-logarithm. We're trying to find the exponent. All right, in question C here, once again we have the natural logarithm to the first power there times x is equal to -4.16. So in this case, the multiplication here, see how this times the starting number, the anti-logarithm, gives you your exponent? They're saying this times our starting number, anti-logarithm, gives us our exponent. So in this case, what are we trying to find? We're trying to find the anti-logarithm. So this looks like e of -4.16 is equal to what number? So in this one, we're going backwards. We're going to hit the shift and then the natural logarithm button. We see the e and then the box there to be able to fill in the exponent. My exponent is a -416. Oh, it's got a point in there, 4.16 equals, and you see my answer there. They change it actually to have a number in the ones place, so scientific notation. So 1.56 times 10 to the -2nd. They moved the decimal place 2 spots there. All right. So that one I had to find the anti-logarithm. Let's look at D. In D here, they do log of x is equal to -4.16. So the log of my x value here is going to my anti-logarithm. They're telling me what the answer to that is. So they're giving me the exponent. So they're saying 10 to the power of -4.16 is equal to what number, what anti-logarithm. So in that one here, I'm going to hit my shift and log. That gives me my 10 to the power of, and then put in my -4.16 and hit equal, and I got my answer there of 6.9. We'll round up to a 2 times 10 to the -5th. Okay, so, and that's my answer there as my anti-logarithm. Okay, let's look at the last practice problem here. These ones, I did the 2 of these in the lesson, so this one's a little more straightforward. 0.00612, and then 576, and then 0.0512 times 10 to the -14th. And they're asking us to use the natural logarithm button to be able to adjust these numbers to then multiply them to then get our answer again. I would agree that it was a lot simpler just to put them all into your calculator and hit enter. However, they're going through this process to show you how you could use this. Okay, so I'm going to put my calculator over here a little bit. Once again, we're going to hit this button here, 0.000612, and so I can write my first one out there as, I'll write it down here, e to the -7. Actually, it turns out to be 40. All right, this next one, I'm going to hit my natural logarithm button. I'm putting 576 equals, and so that one looks like that. And then on the bottom here, I'm going to put in 0.0512, and then times 10, and I get a power in there, so -14. So put all that in there, hit go, and it looks like I get e to the negative 35.21. All right, once I get to that point, I can move this one up by flipping the sign, so 35.21. Then I want to functionally, right, as I multiply exponents out, I'm going to add them. So I'm going to have a negative 7.4 plus a 6.36 plus a 35.21. And that gives me a 34.17 e. All right, and then I want to go backwards a little bit. I've got the exponent. I want to write it as the anti-logarithm. So shift e, put in my 34.17 equals, and I get my answer of 6.92 times 10 to the 14th as an answer. Okay, so the trickiest part to these is actually just making sure you're finding the right thing. Are you trying to find the exponent, or are you trying to find the anti-logarithm, the start number, as I've been calling it there. So I want to make sure you're on your way there. Go ahead and try the two problems in your lesson. This is number 6 that you have to do. So number 6a in the homework is stating x is equal to 1 natural logarithm, okay, the e number there, times 0.0093 is equal to what? So let's ask ourselves, what is this asking? Well, since these two are written next to each other, and then x is equal to that, these two are written next to each other, pretty sure this number right here, that is going to be your anti-logarithm, right? And you're trying to find the exponent. So it's set up as e of x, what is this right here, is equal to 0.0093. Let's see if that is the case. I'm going to do that problem and see if I get the answer that they are looking for. I'm going to check at the back of the book here. Okay, and I do. So yes, on A, we've correctly identified this one's written next to that one as multiplication. So they're giving us the anti-logarithm, and we're trying to find what the natural logarithm, what the exponent is here. All right, let's look at B. On B in the homework, it's set up as e to the exponent is equal to 2.136. Oh, I did that again. I did it on the wrong number. E is equal to 62.5. Okay, so what is that telling us? They're telling us that the exponent of e, okay, when you multiply it by its natural logarithm is this. So once again, they're giving us the anti-log. So if we put that in there, double check that answer. And yes, that is correct. Okay, so once again, they're giving us this setup here. They're trying to find x sitting here. We want to find the exponent. They're giving us the anti-log. Okay, I believe if they want you to find it the other way, they're going to write it. If we look at the next problem there, if we look at 7, let's look at those. Lesson number 7 in the homework, you have in of x is equal to 5163. In that case there, actually the answer for that one is e is 5163. They're showing you that they're giving you this value here, and when you try to do the inverse on that, it doesn't work on the calculator. So I'm not sure about that one. But in B, so in this one here, well, it's just, yeah, they're giving you the exponent. In that case, they were trying to find the anti-log, but they wrote it out that way in the answer key somehow. Yeah, let me double check that there. Yeah, for some reason they put it that way. You get, it doesn't work in the calculator when you try to do it. For b is log of x is equal to 2.136. On this one here, ask ourselves, are they giving us the anti-logarithm or the logarithm? In this case here, x is here, so I believe that they're giving us the anti-logarithm, right? And then they're trying to find what the logarithm is here. Let me see if I'm telling you that correctly. Log of 2. No, actually, I think I told that one. No, I did. I said that one wrong. Okay. Yeah, let's back up here a little bit. All right. So this one here, they're telling us that the logarithm is equal to this. So they're saying 10 times 2.136 is equal to, so the log of x, just like here, when they're written together, they're giving us the antilog. So this right here is the anti-log for that one, and this is the exponent, so it's that way. So you actually want to do that the opposite here. If I put on my calculator, 10, and then you put in the 2.136 equals, and our answer, anti-logarithm of 136.77 on that one. Okay, this is a little tricky, and really the main part is you got to find out, are you trying to find an anti-logarithm or the exponent? And once you find out, then you can set it up correctly. Okay, feel free to text me if you have any questions, and have a great day.